Just a minute. Just a minute, Sean.
Okay.
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 Just a minute, Sean.
It looks like it is full screen at my end. Does it not at yours? It looks like it is full screen at my end. Does it not at yours? It looks like it is full screen at my end. Does it not at yours? It looks like it is full screen at my end. Does it not at yours? It looks like it is full screen at my end. Does it not at yours? It looks like it is full screen at my end. Does it not at yours? It looks like it is full screen at my end. Does it not at yours? It looks like it is full screen at my end. Does it not at yours? It looks like it is full screen at my end. Does it not at yours? It looks like it is full screen at my end. Does it not at yours? It looks like it is full screen at my end. Does it not at yours? It looks like it is full screen at my end. Does it not at yours? It looks like it is full screen at my end. Does it not at yours? It looks like it is full screen at my end. Does it not at yours? It looks like it is full screen at my end. Does it not at yours? It looks like it is full at my end. Does it not at yours? It looks like it is full at my end. Does it not at yours? It looks like it is full at my end. Does it not at yours? It looks like it is full at my end. Does it not at yours? It looks like it is full at my end. Does it looks like it is full at my end. Does it looks like it is full at my end. Does it looks like it is full at my looks like it is full at my Do we have a problem with the live stream? I've just taken my screen down so that I can have a look at you. Yeah, go ahead. It does. It is full on mine. Is that what it looks like for you? Yes. Yeah, I can hear you loud and clear. Okay, perhaps I need to do that in the web platform rather than just on my screen. So I did just have it like that. So if that didn't show through on yours, then that's not working. So now it's in normal view as if I was working on it. And now it's shared. Share my PowerPoint. and then come back to the web app. Yeah. I can't share my screen then because I can't get back to the web app because it's sharing my full screen. Or maybe it's something I have to do on the web platform. Maybe if I stop sharing and we start again. Yeah, maybe if I just share my full screen. Yeah. So when I was doing it before, I was just using the PowerPoint. But if we try, and that wasn't working, so maybe if we try entire screen. Yeah, that looks like it might be working. How about that? Does that look good? Great. No problem. Yeah. Thank you, Tiago, for that very generous introduction. And it's great to be here with you today. The technology doesn't always work the first time round, but how amazing that I can sit in my office in Edinburgh, in Scotland, and speak to all of you in Brazil. So what a great opportunity, and it's lovely to be here with you. So this talk came about because I was lucky enough to host Tiago on a research visit where he came to work in my research group for a whole year, and we had a fantastic time and did lots of great science. And so it's a pleasure to keep that collaboration moving forward and going from strength to strength. So Tiago started by saying a little bit about me, so I'm going to return the favor. So my opening slide is going to show the major currents within and beyond the Southern Ocean that make up the ocean circulation system. So in the orange color here, we have the surface currents, and in the blue color, we have the deep currents. But before I show this video, I just wanted to reflect on one of the first things that Tiago told me when he arrived in Edinburgh. So he told me that, hopefully you can see my arrow, my pointer, that where you are at Ferg and in Rio Grande is closer to Antarctica than it is to Tiago's hometown, way up here in the north of Brazil. And that just blew my mind. That was an absolutely incredible piece of knowledge about how big Brazil is that I didn't know or I hadn't appreciated, and also how close to Antarctica Brazil is. And therefore, a lot of the processes and changes that I'll talk about are directly relevant for Brazil and indeed much further afield. So I'll play this video now, and we can see the major current systems of the global ocean system. And we can see that the Southern Ocean is absolutely central to this system. It takes in water from the Atlantic, the Pacific, and the Indian Oceans, circulates it, mixes it up, integrates all those properties before sending those waters back out to the major ocean basins to the north. And in this way, Antarctica and the Southern Ocean and the processes happening there are globally important and make up a critical part of the global ocean and climate system. So hopefully that didn't make you feel too seasick. It sometimes does when I look at it, but I think it's a lovely video for showing just how central the Southern Ocean is. So on this slide, I summarize some of the reasons why the Southern Ocean is so important at the global scale. So as we've just seen, it occupies a central position in the global ocean circulation system. And this means that it is critical for the transport of ocean properties, and in particular, the transport of heat, nutrients, and carbon dioxide around and throughout the global ocean system. And as Tiago and Rodrigo very well know, and many others in your research group, the Southern Ocean is a critical region for the air-sea exchange of carbon dioxide, and therefore Southern Ocean processes have direct relevance to the Earth's climate and indeed the coupled ocean climate system. And it has a major role in doing some of the mitigation of climate change that is currently being caused by human activity. So there are many estimates as to how important the Southern Ocean is, and it's been estimated that the Southern Ocean has removed up to half of the total atmospheric carbon dioxide that has been taken up by the oceans globally. So the Southern Ocean has done about half of the job that the whole system has done. And then in terms of heat, this number is even higher. So the Southern Ocean has taken up to 3/4 or 75% of the total heat that the oceans have taken up. So the Southern Ocean is critically important in regulating Earth temperature, both directly by taking up heat and indirectly by taking up carbon dioxide, which is a radiative forcing gas or a greenhouse gas in the atmosphere. And this role in climate change is quite well known now, but what is less well known is that the Southern Ocean is also responsible for supplying nutrients throughout the global ocean system. So about 60% of the nutrients that are supplied to the low latitude regions come from the Southern Ocean. And therefore, arguably, Southern Ocean biogeochemistry supports around a similar percent of total ocean productivity. And another major factor of the Southern Ocean and Antarctica is that the seasonal cycle of the sea ice cover is one of the largest, if not the largest, forms of environmental variability on a seasonal cycle anywhere on Earth. So we see some images here from the National Snow and Ice Data Center, and on the left we have the monthly average sea ice extent for last September. So this is the end of the winter when sea ice extent is largest, and we can see at the bottom of this image that its total extent is 18 million square kilometers. And then towards the end of the summer, when the sea ice has melted and decayed away, we see that seasonal minimum value. And this February that has just passed saw the lowest sea ice extent ever recorded in Antarctica. And that extent was just under 2 million square kilometers. So whether or not this area of ocean is covered by sea ice changes every single year, and that area is around 16 million square kilometers that sometimes is covered by this effective lid of the sea ice cover, and other times it's open ocean. And this huge physical variability is critically important to the ecosystems that rely on the sea ice, and indeed the organisms that make them up. So this very large seasonal variability drives strong seasonal cycles in almost every organism that is found in the Southern Ocean, and almost every process. And it won't surprise you to hear that these seasonal sea ice dynamics are changing as a result of human-induced climate change that is currently underway. And I'm going to go into more detail in that now. So these two plots on the left-hand side of the screen show the change over time in the monthly values for sea ice extent for September, winter at the top, and February or summer at the bottom. And what we can see is that over this whole time series, there is not a statistically significant trend in Antarctic sea ice extent. But we do notice a very pronounced or strong change since 2014 or 2015, depending on whether we're looking at September or February, after which the sea ice extent has declined dramatically, both at the end of winter in September and towards the end of summer in February. And we can see down here, again, hopefully you can see my pointer, that we hit the lowest ever recorded sea ice extent in February of this year. Now, these trends are for the whole of the Southern Ocean, and what they don't show is the different regional variability. So in addition to this variability at the whole Southern Ocean scale, we also see strong variability in different regions of the Southern Ocean, some of which where sea ice extent is increasing, and some where it is decreasing, some where it's not changing very much. And the other thing that becomes very clear from these graphs is that whilst there is no overall trend for the whole period, there is significant variability from year to year. Now, the two images on the right, the one on the left shows the percentage change of sea ice concentration per year between the late 1970s and 2014. And the one on the right shows the change in sea ice duration over the same period. And what both of them show is this regional variability where we've had very strong losses of sea ice around West Antarctica and more modest increases in sea ice in the east of Antarctica. But remember that these plots only show data until 2014, before these big reductions occurred. So, to the best of our knowledge, these sea ice reductions are going to continue with ongoing climate change, but the magnitude and the rate and the timing of these changes is not very well constrained. And the reason for that is that the IPCC class models, so the gold standard of climate models, still doesn't do a very good job of replicating the changes in Antarctic sea ice that we've observed so far. So we don't have much confidence in their ability to predict or project what will happen in future. The models are getting better and we're making good improvements, but there is still a long way to go before we can reliably project future changes in Antarctic sea ice. But one thing we can be fairly sure of is that these reductions will continue. Okay, so coming now to the ecosystems that I shall focus on for the rest of this talk. And a lot of the work that I'm going to present comes from the Marine Ecosystem Assessment for the Southern Ocean, or MESO, as you can see in the top right of the screen. Now, this was an international 5-year program which aimed to do a circumpolar assessment of Southern Ocean ecosystems. And it involved over 200 scientists from all over the world, so from 18 different countries. So there was a real focus on inclusivity and making sure that the whole Southern Ocean community was represented. And it was indeed the paper that I led for this project that first introduced me to Rodrigo and Tiago and the beginning of our excellent collaboration. So the main objective of MESO was to assess the status and trends in Southern Ocean ecosystems, the organisms that rely on them, the food webs that make them up, and the biogeochemical processes that underpin them. And this image here is intended to show the ecosystem with an emphasis on those biogeochemical processes. And what we recognize is reasons for which these ecosystems are so productive. And we were able to constrain for the first time really how productive they are and what the importance of this is in its own right, for its own value, but also in influencing regional level processes and indeed global connectivity as Southern Ocean currents transport nutrients and carbon, and as organisms migrate in and out and around the Southern Ocean on an annual basis. And we were also able to quantify for the first time just how complex the structure and functioning of Southern Ocean ecosystems is in both over both time and space scales. And what one of the most striking findings was just how well adapted these organisms are to the extreme environment where they have to deal with really cold temperatures and this extreme seasonal cycle of sea ice. And the reason for that is that this ecosystem has been developing for 25 million years since the southern tip of South America became detached from and started to move away from the northern tip of the Antarctic Peninsula. So that happened over 25 million years ago, but that is the estimated time over which these ecosystems have been developing. And we were also able to show the extent to which life cycles of all organisms in the Southern Ocean are linked to sea ice. And on the previous slide, I showed how sea ice is responding to climate change. And the fact that Southern Ocean ecosystems are so closely tied to sea ice means that those ecosystems are also highly susceptible and sensitive to climate change that is going on at the moment and is expected to continue in future. So we started to be able to talk about how changes in sea ice that are happening are affecting or are driving changes happening in the habitats, species, and food webs that make up these ecosystems, the way they're structured, the way they function, and importantly, the services that they provide to human beings. And I'll talk more about that later. And so for the next few slides, I'm going to talk about some of the most important biogeochemical processes that we identified in the paper that I led with Rodrigo and Tiago and many other great scientists from across the world. So we focused on the ecosystem role in carbon uptake and storage. We examined the cycling and redistribution of nutrients by these ecosystem components, and we were able to make some estimates of the importance of benthic pelagic coupling, so the processes that connect the seafloor ecosystems and the water column ecosystems. So we'll start with carbon uptake and storage and indeed export. And this figure, which is from our paper, gives large-scale averages of the partitioning of organic carbon that is produced by phytoplankton. So let's say we start with 100% phytoplankton. These numbers show what percentage of this initial amount of carbon produced goes into different components of the ecosystem. So about 37% of the carbon is consumed by zooplankton, which are then consumed by higher predators. About 50% of the carbon goes from phytoplankton straight into the microbial loop. So what this means is that the phytoplankton die and are remineralized before they are consumed by zooplankton. 12% of the carbon produced by phytoplankton reaches the seafloor ecosystems and feeds the benthic animals, or the benthos. And then for each of these consuming organisms, so the zooplankton, the higher predators, and the benthos, when they die and their material is degraded or decayed, that also goes into the microbial loop, which is recycled back into the nutrients and carbon that were utilized in the first place to produce organic carbon by the phytoplankton. And once all of that cycling and recycling has happened, approximately 1% of the carbon taken up by phytoplankton is sequestered in the sediments. And this is either because it's exported there directly, or because the things that have consumed it transfer some of their material to the seafloor, which is then buried. So that's the kind of conceptual overview that we came up with based on as many literature values as we could find and a series of unpublished data sets. And whilst the error bars in this are substantial, they are useful indicative values for showing how important each component is in storing and cycling carbon that's been produced by phytoplankton. So this analysis here is it shows the export of POC to 100 meters depth within the water column. So this is aiming to capture the phytoplankton and zooplankton material, which has died and is sinking towards the seafloor. And what we can see is that the POC export is highest around the sub-Antarctic regions, and this is due to the supply of iron from continental land masses, islands like South Georgia Island or the Kerguelen Islands, and indeed the supply of iron from shallow continental shelves. So that is in large part why the Southern Ocean has such an important role to play in taking up and storing carbon, but specifically atmospheric carbon dioxide. So what we can say is that only when Southern Ocean ecosystems are healthy and functioning as they should in their natural state, can they support such large amounts of biological carbon uptake and exports. And this makes a significant contribution to the total uptake of atmospheric CO2, which happens in the Southern Ocean, which in turn makes a substantial contribution to the global total. And for this paper, Tiago did an analysis based on total alkalinity and dissolved inorganic carbon measurements, which compare the contributions of the solubility pump and the biological carbon pump to this carbon uptake and storage on an annual basis. And this analysis showed that the contributions of the solubility pump by physical processes and the biological pump due to primary production by phytoplankton are comparable in size. It was difficult to be any more specific than that, but certainly the variation of these two mechanisms on a seasonal basis indicates that their contribution to total carbon uptake is of a similar magnitude. And again, this is very useful in informing us of the relative importance of these two mechanisms and how they may change going forward. And speaking of how things may change going forward, this new plot that's just appeared shows the change in POC exports by the end of this century. So it's taking the image on the left and saying, how is this going to change by the year 2100? And we can see that there are substantial increases, in particular organic carbon flux around Antarctica, and smaller increases, but increases nonetheless, in the Atlantic sector and Indian sector in particular, in the sub-Antarctic latitudes, so between 40 and 50 degrees south. And elsewhere, particularly between those two bands of latitude, we see reductions in the amount of POC exported over the course of this century. And this banded structure is something that has been seen before, and we were able to further explain why this is likely to happen. And we we concluded that the increases around Antarctica are driven by a greater iron supply due to more exposed land, more iceberg release, faster winds around Antarctica, which transport more iron into the ocean. Also, as the sea ice cover retreats and we have sea ice cover for a shorter period of time, that means we have longer growing seasons and therefore higher total primary production and higher carbon export to depth. So the changes around Antarctica, that bright red colour, is driven by increases in the availability of both iron and light. Whereas in the subantarctic, the leading control is changes in iron supply, which come from the accelerating winds around the Southern Ocean and therefore the increase of dust and therefore iron supply to the Southern Ocean. Whereas elsewhere, we see these declines because we're expecting an overall increase in mixed layer depth, which will have the effect of mixing phytoplankton over a deeper depth interval or a larger depth interval, which means that for quite a lot of the time, they will be in the lower light part of the euphotic zone, maybe even beneath the euphotic zone. And this variable light availability will reduce their overall photosynthetic efficiency, and therefore their growth rates, and therefore the total amount of primary production that they are capable of doing. So we see this banded pattern where both light and iron are important, but they have different importance at the different latitudinal bands. And this is summarized here. In particular, the second point, where we see these increased primary production and carbon export around Antarctica because of increases in both iron and light supply. And with the subantarctic, and building on what I just said about increases in iron supply, there is greater uncertainty in the changes that will happen at the subantarctic latitudes. And that's primarily because we don't yet have a good handle on how phytoplankton species composition will change. We know that it probably will change, but we don't yet have a good idea as to the exact mechanisms by which it will do so, and therefore the exact distributions or changes in distributions of the different species that we can expect. And the different species are driven by changes in physical and biogeochemical conditions, and they have a major impact on both primary production and carbon export, because some species are exported more efficiently or less efficiently than others. But what we do know is that if we sum up these values for the Southern Ocean as a whole, and we take it as one region, then we do expect to see increases in primary production and carbon export overall, and therefore a stronger biological carbon pump in the Southern Ocean as a result of the climate and environmental changes underway. Okay, so what do these changes in primary production mean in terms of nutrients? Talked about carbon, now we'll talk about nutrients. And just to remind you that it's estimated that 60% of nutrients delivered to the low latitude regions come from the Southern Ocean. So the Southern Ocean is a huge source of nutrients for the rest of the global ocean system. But if we see an increase in primary production, as is projected around Antarctica, that means that there are more nutrients taken up around Antarctica. And that means that there are less nutrients or a lower availability of nutrients to be incorporated into intermediate and mode waters that form in the subantarctic to then be carried further north. So that means that the nutrient supply to the north from the Southern Ocean is very likely to reduce because more of those nutrients are trapped within the Southern Ocean rather than being available to be transported further north. So if we have less nutrient export going north of 30 degrees south, that means that less nutrients are going to upwell in the low latitude regions. And this is particularly important because the low latitude regions are currently nutrient limited, so macronutrient limited, whereas the Southern Ocean is micronutrient limited. And what this means is that increases in primary production in the Southern Ocean are likely to lead to large-scale decreases in primary production in the lower latitudes. And thinking again back to the relevance of these changes for Brazil, I'll just remind you that there were currents coming from the Southern Ocean that travel along the Brazilian coast, as some of Tiago's work has shown us recently. And there is another Southern Ocean current which comes up the Pacific side of South America. So these currents and these biogeochemical responses that are being transported away from the Southern Ocean towards the north are likely to have direct implications for nutrient supply and therefore primary production off the coast of Brazil and on the Pacific, off the Pacific coast of South America. So major relevance to Brazil and neighboring countries, and where this is most likely to bite in terms of the general population is that primary production in these regions and all regions is critical in supporting fish populations, fish stocks, and therefore not only supporting fisheries and therefore being very important economically, but also in underpinning food security and enabling people to be adequately nourished based on products from the sea. So whilst the Southern Ocean may in some ways seem more remote and less important than waters immediately offshore, actually their long distance effects are incredibly important, both socially and economically for Brazil, as well as for us in the UK and indeed globally. So the global fisheries value, the value of the global fishery industry is approximately $200 billion US. So there's a lot at stake economically if these fisheries start to collapse because of changed nutrient supply from the Southern Ocean, and there's a lot at stake socially in terms of underpinning food security in Brazil, the UK, and many, many other countries. So it was actually for a policy briefing for the European Union that I first started thinking through these things, because my brief was this is for European Commission ministers, and therefore it needs to be directly relevant to Europe, at which point I thought, easy, because it is directly relevant to Europe as much as it is for South America, Africa, North America, everywhere. You get the point. So yeah, real important implications of changes in the Southern Ocean in terms of carbon and nutrients at the global scale. And I said I'd talk a little bit about benthic pelagic coupling and the role of animals in biogeochemical processes at the large scale. So this is also from the MESO project. It was a paper led by my colleague Eugene Murphy, who lots of you know as well. And what we did in this paper is to try to estimate the annual migrations into and out of the Southern Ocean and understand what that means for the transfer of carbon and nutrients into out of and around the Southern Ocean on a seasonal basis. So we found that in terms of seabirds, and this is all flighted seabirds, so not penguins, but all other birds. And we found that 68 million birds fly in and out on a seasonal basis, which makes a mass of about 18,000 tons. And the prey demand of these predators, so their demand for food, is significantly higher during the summer, because that's when they come to the Southern Ocean to eat. And then when they fly back north again, they transport the carbon and nutrients that they've taken up in that feeding throughout their migratory route. Similarly, for the cetaceans in the lower figure, we found substantial movements of mass in and out of the Southern Ocean on an annual basis. So we found that there were approximately 600,000 cetaceans migrating seasonally, and this gave a mass of about 8 million tons. So that's an awful lot of carbon and an awful lot of nutrients being moved within, around, and in and out of the Southern Ocean on an annual basis. So this means that animals contribute significantly to the uptake of carbon, but possibly more importantly, the storage of nutrients and carbon over often quite long periods of time. So if we think of a blue whale, for instance, they weigh almost 100 tons per organism, and they can live for almost 100 years. So that's a lot of carbon and nutrients stored for a long time, and therefore the role of animals cannot be ignored when talking about uptake and storage of carbon and nutrients in the Southern Ocean, and the redistribution of that carbon and those nutrients at the global scale, which again means that the Southern Ocean is critically important for connectivity, both through the currents moving throughout the global system, but also the animals moving in and out on an annual basis. And because the impacts of climate change are felt by these organisms when they're in the Southern Ocean, and indeed when they're anywhere else, that means that these migratory behaviours and their biogeochemical implications are also susceptible to climate change impacts and human activity. And then I want to, for the final part of my talk today, I want to change gears a little bit and focus in more on those human interactions with the Southern Ocean ecosystems and the services that they provide. And I'm hoping that in addition to Tiago, there's some early career researchers in the audience who may be interested in doing some policy work and contributing in that way. So I hope to drop in a few ideas as to how you might do that. And then for the more senior or the more wise among you, I'm sure many of you already are doing policy work, but I wanted to use this talk as a bit of an opportunity to say, I and we and others are doing societal work at reasonably large scales for the Southern Ocean, and there is always room for more hands on deck. So if you are interested in getting involved in that, then I would love to see our collaboration facilitating that involvement. Okay, so what I'm doing on this slide is I'm characterizing Southern Ocean ecosystem processes as ecosystem services, because my experience in policy work so far is that if you can't relate importance to human beings, people don't listen for very long. Whereas if you can talk about the ecosystem services that an ocean system provides and the societal benefits that it enables, then people are much more interested and much more willing to make interventions that are necessary to protect and safeguard these systems. So instead of, as scientists, talking about carbon uptake and cycling and sequestration, if we start to talk about that in terms of blue carbon and a regulating control on our climate, then people start to see that it's important for them because they know that the world is changing because of climate change. So if we can communicate the value of these ocean systems in supporting that process, then people are much more likely to pay attention. And in brackets underneath each of these statements, I've put the type of ecosystem service that these things are characterized as. And then instead of just thinking of Antarctic biodiversity as this distant thing, it really is being celebrated more and more as a global inheritance. It's a deep cultural, or it's a deep valuable ecosystem service that has very important cultural meaning and cultural value for a huge range of people. And tied very closely to that is the importance of the Southern Ocean in underpinning food security and filling our fisheries with lots of products that human society wants and needs. And then instead of talking about nutrient supply and cycling, and not to mention isotopes, because that's a very easy way to lose people who are not scientists, but instead, if we can talk about the Southern Ocean as supporting ocean health and productivity at the global scale, then it becomes much more tangible for people who are not scientists. So also as part of MISO, we did an assessment of the main stressors on these Southern Ocean ecosystems and the services that they provide. So these are some large-scale drivers associated with global human-induced climate change. But on top of these, we've also got the impacts of human activity within the Southern Ocean, the majority of which are increasing in intensity. The only one that could be perceived as good news, as us making progress, is the recovery of marine mammals from when they were harvested almost to extinction about 70 or 80 years ago. So there are these direct local drivers associated with human activity in the Southern Ocean, and these are essentially lowering the resilience of these ecosystems to changes in the climate and the environment that we are imposing onto them, making them even less able to cope with the changes that we are subjecting them to. But it's important to remember that we're thinking about a multiple stressor system, and therefore we're not just thinking about each of these stressors individually, but we're talking about the way that they combine, the way they interact, and the way that they respond to each other, and other components of the system respond to them. So a very kind of intense multiple stressor situation, and the complexity of the stresses really requires a complex response in terms of policy making. So in terms of how things are already changing, we're seeing southward contractions of the Antarctic krill on the left-hand side there. And this means that any species that are reliant on krill as a food source or reliant on sea ice as a habitat are also reducing in abundance and seeing local declines in places where they used to be very abundant. And the classic example of this is the Adelie penguin in this middle picture, which is showing that its numbers are declining rapidly along the Antarctic Peninsula as the conditions become more maritime, warmer, the sea ice is reducing, and therefore they're losing their habitat, and the krill populations are becoming more localized, as well as threatened by commercial fisheries activities. But the image on the right of some benthic organisms just off of Rothera Station shows, or is designed to show, that as there are declines happening. There are also species that are doing well. So those species that are adapted to more northerly environments or more temperate, warmer conditions, or they're just more resilient to change, they're actually doing well as other species decline in abundance. So taken together, this means that what we're seeing is major shifts in the composition of ecosystems and food webs. And this drives strong changes in the biogeochemical processes that underpin these food webs. What we also need to recognize is that as key components and functions are lost, there are not only going to be local consequences, but also regional and global. And coming back to the ecosystem services narrative, we are really starting to see that the changes occurring in the Southern Ocean are affecting the entire global system, and critically, and this is the newer bit, its human population. So in terms of some work that I've been doing about it with many others from the international community, is really pushing the message that action required to safeguard Southern Ocean ecosystems needs to happen across scales in a way that is both urgent, as in it starts now or it improves now, but it continues for the long term. And these images on the slide show the product of an art project that sat alongside the MISO research project and enabled us to communicate the findings to a much larger audience. So it essentially shows that if we stay within 1.5 degrees warming compared to pre-industrial levels, the Southern Ocean ecosystems will remain stable. That doesn't mean they won't change at all, but they will be able to maintain their stability and their long-term longevity. Whereas if we see warming beyond our limits, which here is defined as 2 degrees, so we break through the Paris Agreement ceiling, then we see devastation to Southern Ocean ecosystems due to the warming and acidification of waters and the loss of large components of the ecosystem. First of all, the seafloor ecosystems as ocean acidification takes hold, but then the wider ecosystem in time. So the solution to this is that we need policy at the global level and at the local level. So there are global drivers which are beyond the scope of any kind of regional governance framework or policy framework, and therefore we really do need global policy on climate change mitigation. It is the only foolproof way of safeguarding these ecosystems and the services that they provide. But in order to enhance the resilience of these ecosystems and to provide refuges from which species can then recover, local management is also very important, and marine protected areas could play a very effective role in this. I could give a whole talk about marine protected areas in the Southern Ocean and the progress towards establishing more. Suffice to say, there has been some progress, but there is space for a lot more. And the local and regional approaches to conservation and management absolutely need to be precautionary. They need to be very careful. They need to allow for big buffer zones in terms of making sure that our impacts are within the limits of what these ecosystems can cope with. And it also needs to be responsive, which means that it needs to be supported by excellent high quality research and long-term monitoring beyond just the time scale of 2 to 3 year projects, but we need long-term monitoring. And that needs to be delivered, in my view at least, by a very inclusive international community where everybody has a seat at the table and everybody has a contribution to make. And it's exactly the same for policy making. So we need an inclusive and well-connected or well-integrated multiple stakeholder approach that involves national entities, industry and the private sector, as well as the main intergovernmental systems of the Antarctic Treaty System, the Commission for the Convention on Antarctic Marine Living Resources, the UN Framework Convention on Climate Change, and the involvement of a large and diverse range of non-governmental organisations. So at COP27, which was the last big policy event that I did, it was in Egypt in November last year, we got together as representatives of various organisations from the Southern Ocean community to really emphasise that message that protection of the Southern Ocean needs to happen at the global scale and the local and regional scale. So these four groups got together within the wider context of the international community involvement in the United Nations Decade of Ocean Science for Sustainable Development. And this is a critical part of making sure that all relevant stakeholders have a seat at the table. And then whether we're talking about Antarctic Treaty System or whether we're talking about the United Nations instruments, the most important lesson that I've learned in terms of the differences between policy and science is that in science, we're always coming up with things that are new. It always has to be new, it always has to be improved, it always has to be innovative, drives a step change in knowledge, all of these things. Whereas in policy, actually the most important thing is to be consistent. So between these different policy events, we always come with the same message that is expanded and developed and elaborated, but at the core, it's the same message, because that consistency of message is so important to informing policy and to removing doubt that if we come up with something new, does that mean that the other thing was wrong? So we really need to keep a message that's consistent, that's clear, and that is succinct. So is as condensed or short as possible, because policymakers are busy people. So if your message is not very succinct, you'll lose their attention to something that they perceive as more urgent. So my key reflection on policy work is that it's very different to doing science, but the key things are that your message is consistent, clear, and succinct. So this is the team at actually COP26, this one, and we went there to advocate for urgent global reductions in greenhouse gas emissions in order to mitigate global climate change, because this was a United Nations Framework Convention on Climate Change conference. So that was our main message. But then our side message was that this needs to happen alongside effective local conservation and management to ultimately safeguard these ecosystems and the many, many societal benefits that they have. And depending on which policy setting we are in, we might change the emphasis of the message in terms of whether we're aiming at a global audience or a local audience, but the core message is the same. So, and this is a team of us at the UN Oceans Conference in Portugal last year, where we were given the only in-person event for the polar oceans. And given that this was the United Nations Ocean Conference, that was quite a big surprise. So again, it showed us that there is still lots of work to do in ensuring that the polar regions have an equal voice to other oceans around the world, and that ultimately they are safeguarded against climate change and the direct impacts of human activity. Okay, so wrapping up now, I will just give a very brief overview of what has been achieved in the United Nations space over the last couple of years since I've been involved. So the result of COP26 of which our session was a very small part, but there was lots of other things that went on to lead to the oceans being formally included in the cover decision for the first time. And the cover decision is the formal text that comes from the conference. So that was a big achievement that the oceans were formally included. And as part of the recognition that led to that, it was also agreed that there would be an annual dialogue on the oceans and their role in climate change. So that was a big step forward for the oceans. And then in COP27, there was an increasing focus on the ocean's role in both mitigating and adapting to the climate change challenge, which again is the first time that has happened. And there was also a formal presence for the oceans in the United Nations Blue Zone, which is the formal exhibiting space of the conference. So there was a real voice for the oceans in the way that there hadn't been before. And then for those of us more interested in the polar oceans, there was a formal declaration signed by 19 countries at the time, which was a declaration for ambition on melting ice. So in my opinion, the name of this is not as good as it could be, but what essentially the declaration says is that we need to stick to 1.5 or at most 2 degrees warming in order to protect the cryosphere, which will safeguard the cryosphere, but also human populations against sea level rise and loss of mountain glacier resources, running water, and the effects that has on sanitation and health. And there is a workshop to further that, the work of that declaration at the forthcoming climate change meetings in Germany, which act as the other main part of the UN climate change process outside of the COPs. So there's a lot of momentum there, but a lot of work still to do. And it's really that note that I want to finish on today, that in terms of our understanding of the polar regions, driven by great research groups worldwide, including the one that I'm speaking to today. The science is really coming on apace. We're developing our understanding all of the time, and also in the way that science is being translated into policy. We're gathering pace, we're gathering momentum, but there is still an awful lot of work to do. So it really is a case of needing all hands on deck. So if you're interested in becoming involved in these sorts of things, then I'd be delighted to talk further. Okay, so final slide now is just the summary. I will leave it up there for you to read yourselves because I see I'm slightly over time. Actually, Tiago didn't give me a time, so I could speak all morning for you, but I won't. Yeah, but I suspect I've talked for long enough. So I'll really just finish with the key message that the sooner we take action on safeguarding the Southern Ocean and its ecosystems, and in mitigating global climate change, the less we will have to do to get us back to a safe space where these ecosystems and these global systems are safeguarded and can continue to provide the services that they provide to global society now and into the future. So thank you very much for listening. It's great to be here with you. Hopefully next time I might be there in person, who knows? But yeah, happy to take any questions.
Okay, just...
I forgot the last bit. There's the last bit. I think something might be wrong with this app. a lot of illegal and unrecorded fisheries activity, which could be causing food insecurity, 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 which could be causing food insecurity.
The room's okay, anyway, right? The room's okay, anyway, right? And well, and we have another question from the Professor Eduardo Secchi that it's about the MPAs, I think it's marine protection areas, that it would be great if you, Dr. Sian Henley, could give us a talk on MPAs and how to define appropriate criteria for defining priority areas that could be candidated to become new MPAs.
Yeah, so I could, like I say, I could talk all day about MPAs in the Southern Ocean. I think the key thing, the key barrier, is political will. I think the two reasons that are given for which new MPAs have not been approved in the last 4 years now is that there's not enough evidence to support the need, and that we don't yet understand the balance between conservation and rational use, which is a term used to say this is how much we can use and it's okay. So those are the two reasons cited for blocking MPAs by the countries who block them. I actually think that it's entirely political. So the key challenge is persuading the people who have control in those countries, which really means reaching out to the society, because I think political will is a very complicated thing, and it's far too complicated for me to understand in full. But I think in simple terms, political will comes from societal will, so it comes from the people, and therefore the more the people put pressure on the politicians to make these decisions, the more likely they are to do that. And that is just as true in the UK and in Scotland and in my local area as it is in marine protected areas in the Southern Ocean. But I think we are at a tipping point in terms of society where we will see more action in terms of marine protection because it's higher profile. More people know about it, more people care about it, and more people want to do something about it. And I think the younger generations are critically important for that. They're getting angry, and that's really good to see in terms of being an effective way to drive change.
Yeah, thank you very much. And I was very pleasure to see you show the importance of the spread and share the scientific knowledge more accessible to ordinary people, because I think this is a problem that we see all over the world, here in Brazil as well, and there in the UK. And so we have another question from Mateus. That is, hi Sean, thank you very much for your excellent talk. And I have a question for you. Do you think it's possible that in the next years we have changes in the phytoplankton groups, dominance of the Southern Ocean, and what would be the impact of the one on the carbon biological pump?
It's an excellent question and one that lots of people are working on. So there are two main drivers of changes in phytoplankton. One is temperature and the other is ocean acidification. So in terms of temperature, we're expecting species in general to move southwards towards Antarctica. So we'll see species that would previously have lived further north in more temperate regions coming further south and into the Southern Ocean. So this might well lead to a decline in the dominance of diatoms. And if that happens, then we could expect to see a reduction in carbon export because diatoms export carbon very efficiently, whereas other smaller species do not. In terms of ocean acidification, it's more complicated. There are several studies that have looked at the impacts of ocean acidification on different species, and the results have been pretty variable. So in some cases, acidification leads to a shift of larger, more heavily silicified diatoms. In other cases, it does the opposite. In some cases, it leads to shifts between diatom dominance and dominance of other groups. Other times it doesn't. And then something we're understanding more and more about is the effect on the microbial loop of ocean acidification, which could accelerate the recycling of organic carbon and therefore mean that even if lots is taken up in the surface ocean, the degree to which it is exported to depth may decline. But then there is one other study which shows the opposite of that. So I think there's a lot more work to be done. And my best guess would be that we'll see a very patchy response. So there will be changes in different directions in different parts of the Southern Ocean. But overall, we can probably expect to see more of a transition. So slower than a shift, but a continuum perhaps towards smaller species that may be less efficient at exporting carbon. Oh, I've lost you for sound, Tiago. I've lost you for sound, Tiago. I've lost you for sound.
Sorry.
Yeah, that's better.
Sorry, my phone. So I have a question about the benthos. Let me see here. Okay. Thanks, Dr. Sean, for your interesting presentation. My questions will be regarding the research on benthos. What do you think is more urgent to research in terms of the benth community?
What is more what to research? What is more what?
What do you think is more urgent to research in terms of the benthos?
Thank you. Yeah, nice question. I think the most important thing is to get baseline data for ecosystems that are emerging from underneath receding ice shelves and glacier fronts. So a good example would be the island in Potter Cove, which Argentinian colleagues are leading on, and they have done a great job of surveying the communities there, partly to understand how things change in terms of ecology when the physical environment changes really quickly. I think we can learn a lot from that in terms of fundamental biology, but also community ecology and climate change interactions and biogeochemistry, but also in terms of protection. Some of these places are incredibly biodiverse, incredibly rich, and incredibly important in ecosystem connectivity. So they are a high priority for protection. And some good news from the policy world is that CAMLA have new regulations as of about 2 or 3 years ago. 2 or 3, which is that when habitats emerge due to changes in the cryosphere, they cannot be fished, they cannot be exploited for 10 years. And that allows time for enough data to be collected so that we can understand whether any fisheries activity in that region would be sustainable or not.
Okay.
And then my other big priority for the benthic ecosystems would be ocean acidification, because they are expected to be exposed first as the aragonite saturation horizon shallows. I forget the exact numbers, but we're expecting it to shoal by several hundreds of meters in the coming decades. And for benthic ecosystems on the slope, that ultimately means that they're currently in waters that are not acidifying, but quite shortly they will be. So understanding and wherever possible enhancing their resilience to those changes, I think is of extreme importance.
Thank you very much, Sean. And so the last question from our audience is from Andres. From Youngos. It's about the reduction of nutrients. So his question is the reduction in the transport of nutrients to lower latitudes is only caused by the increased biological productivity close to the Antarctic, or change in the circulation patterns also plays an important role.
Yeah, that's an excellent question, an excellent point. So we know lots of things about this, and we don't know lots of things about this. So we know that nutrients are transported northwards, we know that there are changes in the strength of overturning, and we know that at present that is weakening because of changes in density and stratification related to freshwater inputs. So it is very logical or sensible to think that that could have an impact on reducing nutrient supply further north. There are not many studies that have looked at it. There is an important one that has, which projected changes out to 2300, because what we tend to see is if you project to 2050 or 2100, it's not really a long enough time scale to be able to tell, but if you project out to 2300, you can see a tangible effect of slowing ocean circulation. But even that study shows that it's the reduction in the nutrient content of the subantarctic mode water that is a more important control on nutrient supply to the lower latitudes than changes in the physical circulation that transport them there. So a more simplistic way to summarize that would be to say that it will certainly have an effect more over longer timescales than shorter ones, but its effect will still not be as important as changes in the nutrient content of the waters being exported from the Southern Ocean.
Okay, thank you very much. We have a lot of thank you very much. We have thanks here from our audience, from some professors, such as like Elisa is our professor here. She said, "Thank you so much for this exciting talk, and I was delighted to hear about the high-level science carried out by our group, and something from Professor Eduardo as well. And so I have just one last question for myself. Actually, it's about we are about to bring the COP30 to Brazil. I think in the coming years, and I will probably try to get involved. And by your experience in COP26 and 26 and 27, what do you think it's possible to us to do to convince the civil society, about the importance of the Southern Ocean and the oceans as a whole? You said about the importance of translating the importance of the to the civil society, and we have a lot of impact here where we live, and I think that would be even harder to explain the importance of the Southern Ocean to people living in Scotland and in the UK because we are closer. But what do you think we can do to try, to get involved people, ordinary people and civil society in these things when we will get the COP30?
So I think in terms of the key messages for Brazil, and I might be missing one or some because I don't live in Brazil and it's not my area of expertise, but from what I do know, I think there are 4 priority areas. I think the first one for us, but maybe not the first for people, is the Southern Ocean's role in climate change, and therefore the increasing extreme weather, relation to desertification in the Amazon region, changes in predictability of precipitation, all of which will be affecting people in Brazil, is directly related to changes in the Southern Ocean. Fisheries, as I mentioned, I think is an important one in terms of the Southern Ocean's role in supporting food security in Brazil and other South American countries. There is very strong evidence of the link between Antarctic sea ice and atmospheric conditions over the southern part of South America, and in terms of what it enables in terms of agriculture because of the predictability of the weather. And I think that is true for the lower part of Brazil. I don't think it stops further south than that. But the one that I suspect will have the biggest impact on people is when you talk in terms of money. So I don't really like doing this because the error bars are huge and I don't think we should focus on money all the time. But I did a calculation for one of my lectures for the course that you came to last year, which was the economic value of carbon uptake by the Southern Ocean. And I used the central estimate from the latest global carbon budget, and I multiplied it by the UK government's price for carbon credits. So you would have to look at the Brazilian government's price. But when I did it in the UK context, the total, and I did it in US dollars, so it was internationally accessible, was 58 billion. When I think when you start throwing numbers like that around, people who are driven by money, and lots of people are, start to take it seriously. So I think doing some simple calculations to give examples of the value of what we're talking about is huge. And then I think the final message that you should try and convey throughout, and it's one that I try to convey all the time, is that we can make a difference. We can turn this around by doing actions at the very small scale and the very large scale. And only by doing all of those things will we be successful.
Okay. Thank you very much. I saw the calculation about the money by my community did. The COP was very nice and surprised to see. So thank you very much.
So my calculation was an update of Mike's, and I reduced the error bars a little bit by doing some more calculations, but it was the same idea.
Okay, Sean, thank you very much again. It's very nice to see your talks. I always see you on YouTube when I when I have some time. So you're welcome to give us some talk anytime you want. Thank you.
Great. Well, thank you all for having me. It's been a real pleasure. And it's nice to see you all in this digital world. And I hope to see you in the real world sometime soon.
Thank you.
Okay.
Thank you.
And I'll see you at the SUS Symposium.
Hopefully. I will turn off here.
Okay, great. See you soon. Thanks, everyone. Nice to see you all.